Hello students, we will talk about radiopharmaceuticals. Many heavy metals like uranium, thorium, radium and their compounds emit radiation spontaneously. So these radiations can penetrate through the solid materials, they can ionize the gases and produce a glow on the zinc sulfate paint or affect the photographic plates. The substances which emit such radiations are called as radioactive substances, and we call this phenomenon as radioactivity. They are independent of temperature, pressure, or concentration or analyzed. So, what are radioisotopes? Every atom of an element is composed of nucleus containing protons and neutrons surrounded by electrons. If the atom is electrically neutral, that means the number of protons is equal to the number of electrons. The atomic number of an atom is a characteristic of that element. Now we have two major types of isotopes. The stable isotope, which do not decompose to the other isotopic form of the element, and the unstable or the radioactive isotope, that is a radionuclide, which decomposes or decay by emitting the nuclear particles into the other isotope or different elements. Now, when we say radioactive decay, the radioactive substances or disintegrate or decay with the emission of certain particles or certain quantity of energy, which is always associated with the isotope characteristic. So the emissions are alpha rays, beta rays and gamma rays. Now where these properties are used? This is a very important application of radioisotope. One is in diagnostic therapy, radiotherapy, sterilization technique. This is very important use in research applications and analytical applications. Let us first talk about properties of alpha, beta, gamma radiations. Now when we say alpha rays consist of alpha particles. So when alpha particle is emitted, the atomic number decreases by 2 and the mass number decreases by 4. These particles are positively charged particles. The penetration power is low, then ionization power is very high. Alpha particles have low speed. They are affected by strong magnetic and electric fields. No application they have in pharmacy. This is identical with helium nucleus. Now if we see the properties of beta particles, these when are emitted, the atomic number is increased by 1, mass number is not changed. They are positively charged, negatively charged particles are also common. Penetration power is more than alpha particles. Ionization power is less than alpha, and they have more speed than alpha particles. They are affected by strong magnetic and electric fields. They don't find application in pharmacy. Now let us talk about properties of gamma particles. When gamma radiation is emitted, there is no change in atomic or atomic mass. They do not have charge, but they have energy. The penetration power is more than alpha and beta particles. Ionization power is very less. They have the speed equal to that of light. They are not affected by strong magnetic and electric field, and they are useful in sterilization. We have ionization chamber, proportional counters, GM counter, that is Geiger-Müller counter, scintillation counter and semiconductor detectors, and also photographic plate method. So we'll only talk about here Geiger-Müller counter, that is a method for measurement of radiation. If we see the diagram is shown here, this is a working component of a Geiger-Müller counter. You can see the pulse counting electronics, then there is 1500 volt supplier, and you have a detector, you have a source. So from the source you can see the radiation is going, and then you can see the readings, how it is. Let us see the working and construction. Now this consists of a stainless steel or the glass cylinder which is coated with silver or iron on the inner side, which act as a cathode. Then a fine metal wire is mounted coaxially inside the cylinder that will act as an anode. And now the cylinder is filled with argon gas. Radiations will enter through the window. Because of the radiation, the gas is ionized, and you have the high voltage of 800 to 1300 volts will be maintained within the electrodes. Because of ionization of the argon gas, the positively charged ions are attracted towards cathode, negatively charged ions are attracted towards anode. The passage of these ions through the tube constitutes the flow of current. Each particle of radiation will cause a brief flow or pulse of current, which is recorded by the device called a scaler, and then the scaler shows the number of pulses and the result is analyzed. Now we'll see what precautions we should take while handling and storing the radioactive materials. Now because they are emitting certain kind of radiations, they must be having some effect on our body also. So radioactive substances should never be touched with hand but handled with forceps. Secondly, there should be proper disposal of radioactive materials. They should be kept in remote area. Then the fluorescence should be removable. The amount of wood material should be minimum. The worker should wear the protective clothes. We will talk about radioactive contrast media. Radio-opaque contrast media is also called as X-ray contrast media. Now these are the substances which have the capacity to prevent the passage of X-rays, and hence they are opaque on X-ray examination. We call them as radio-opaque substances. Now the medium which gives this type of phenomenon is called radio-opaque contrast media. The substances are administered by oral route and very rarely by IV route. The ideal requirements of the radioactive substances are as follows. It should prevent the passage of X-rays. It should have adequate radio opacity. It should be stable. It should have high solubility. It should be non-toxic. It should be chemically and physiologically inert. It should be easily extracted from the body, and it should also have the capacity to accumulate at the desired site for desired time. Now we will see method of preparation uses of barium sulfate. Barium sulfate is used as a radio-opaque contrast media. The formula is BaSO4. Synonym is barium metal. Method of preparation: it is prepared by precipitation of barium ions from the cold and dilute solution of barium salt with dilute H2SO4. Then the precipitate is washed and dried. We will see the properties. It is a fine, odorless, white, tasteless and bulky powder insoluble in water. This is not absorbed from GIT, and this is soluble in concentrated H2SO4. The dosage 200 to 400 grams orally. The action and uses: this is used for X-ray examination in alimentary canal, orally or by enema for examination of colon, and this is used for the preparation of barium sulfate compound water. Let us see the uses of radioisotopes. Now radioisotopes, we have many of them, and they find their use in medicine in therapeutic diagnostic purpose, in research for study of metabolic processes, for synthesis of several compounds. We'll discuss the more important radioisotopes. First one is calcium. Now calcium 44 and calcium 45 is used to study the bone structure and in the treatment of bone cancer. Cobalt 60 is used for sterilization of surgical dressings. Cyanocobalamin CO57 is used for the diagnosis of pernicious anemia. Gold, AU 198, in the treatment of cancer. Iodine, to study thyroid uptake. Hydrogen, that is deuterium, and proton H1 and H2, that is for the treatment of total body water. Oxygen, 17O18, used in the study of photosynthesis. Sodium, 2224, for the estimation of extracellular fluid. Iron, Fe55, Fe59, to measure the lifespan of RBCs. And carbon 14 for metabolism of fats and carbohydrates. Thank you, students. You can get the notes in the description, which I have given in the link